Good morning, everyone. Happy snow day. Today I'm going to give the lecture on Unit 4.1, which covers types of numbers. So this is a nice break from quadratic equations. It's kind of a clean slate, and there's no computations involved, no calculations. It's just a matter of definitions. So let's just jump right in here and talk about the different types of numbers. So we're going to start in the innermost circle here and talk about natural numbers. Now, natural numbers, these are numbers that a caveman could understand. They're the most early numbers that were ever used or invented or thought about. For example, a caveman would understand 1 and 2 and 3, all the way up to as high as a caveman could count to. Now, around 700 AD, people in India came up with the idea of zero. And it took a while for that to catch on in the West, but eventually it became an integral part of our number system. And that's why the numbers I'm writing right now are Indian Arabic numerals, and I'm not writing Roman numerals. These are much easier to use. Okay, so the difference between the natural numbers and the whole numbers is the whole numbers have this very helpful number called zero. Now, at a certain point, people started thinking of negative numbers in their own right. And so we have numbers like -5, -4, -3, -2, -1, 0, and then we've got the whole numbers all the way up. So integers are basically the whole numbers, but the positive and negative, both positive and negative. So whole numbers are only positive. Integers have both positives and negative numbers, but no fractions and no decimals. Speaking of fractions and decimals, fraction and decimals are rational numbers. Let's talk about rational numbers. Rational numbers are things that can be written as a ratio of two numbers, as a fraction. So, for example, 3/1 is a rational number because you can write it as a ratio, a comparison of two numbers. 1/2, 1/4, 27/39. These are all rational numbers. Okay, now irrational numbers are numbers that you can't write as a fraction. The most famous one is probably pi, but also the square root of 2 or the square root of 3. Those are all irrational numbers because if I was to type this into an infinitely powerful calculator, it would just give a bunch of decimals that would go on infinitely long. Okay, we also have pure imaginary numbers. Now, pure imaginary numbers, remember, imaginary numbers stem from the square root of -1, which is I. And if we doubled that and had two i's, that's a purely imaginary number. If we had 3i or -7/2 I, these are pure imaginary numbers. Now, complex numbers are combinations of pure and complex numbers are combinations of real numbers and imaginary numbers. Okay, so the real numbers are rational numbers, irrational numbers. Basically, anything that's not imaginary is a real number. Now, if I did something like this, 3 plus 6i, 3 is the real part. 6i, this bit, is an imaginary number. So the combination of real and imaginary is a complex number. Okay, now these circles are important. For example, every natural number is also a whole number, and it's also an integer. It's also a rational number, it's also a real number, it's also a complex number. So the things that are most embedded here have the most labels. Integers are also rational numbers, they're also real numbers, they're also complex numbers. And let's do another one. Irrational numbers. Irrational numbers are real numbers, they're also complex numbers. Okay, so here, let me just go out of this for a sec. Here, there's some lists of different things. So natural numbers, just 1, 2, 3, 4, 5, 6, 7, 8. Whole numbers start with 0, 1, 2, 3, 4, 5. Integers have negative and positive. And let's talk about rational numbers a little bit more. So let me go in and mark this up. So decimals that don't go on forever are rational numbers. So for example, 0.25 is a rational number because we can write this as 1/4. So you can write this as 25 over 100, or 1/4. Now this random collection of numbers is also a rational number because it ends. Because it ends, I can write this as 1, 3, 8, 2, 1 over 1, 0, 0, 0, 0. Bunch of zeros. Okay, 100,000. So 13,821 100,000ths is the same thing as that decimal. So if a decimal stops, then it is a rational number. Now, decimals that repeat are also a rational number. For example, 0.333333333333. I can just write this as 1/3. And for this one, there's a little trick here. If you ever see a repeating decimal, you can put it over something like 9 or 99 or 999. It's going to repeat. So for example, if I did 123 over 999, then it would be 0.123123. And if you have a calculator at home, you can give that a try. It's kind of fun. So anyways, decimals that stop and decimals that repeat in a predictable pattern, these are both rational numbers. So what kind of decimals are not rational numbers? Well, decimals that are not rational numbers are numbers that go on forever. Let me write this. So crazy decimals that, oh, I can spell here. I'll try that again. Crazy decimals that both never end and never repeat in a predictable pattern. Okay, so if you type something into a calculator and it turns into a crazy decimal, chances are it's an irrational number. Okay, now irrational numbers cannot be expressed as a fraction. Two numbers that are irrational numbers, for example, pi, square root of 2. Two examples that are not irrational numbers, 3, -7. Can a number be both rational and irrational? No. These are mutually exclusive categories. You either can write something as a fraction, rational, or you cannot write something as a fraction, irrational, but you cannot do both at the same time. Okay, so let's go ahead and categorize these things here and talk about where these fit in. Okay, so 0 is not a natural number because it's something that took us, especially here in the West, kind of a while to accept. It is a whole number, it is an integer, it is a rational number, and it is a complex number. It's a rational number because I can write 0 as 0 over 1 as a fraction. Okay, -3/4, it's not natural, it's not whole, it's not an integer, it is rational, and it is complex. 0.11, same deal, not natural, not whole, not an integer, rational, complex. Pi is none of these except for complex. In fact, all of these, I'm just going to mark these. These are all complex. Everything is a complex number. Okay, square root of 3, same deal. It's not natural, not whole, not an integer, not rational. Square root of 4, trick question. Square root of 4 is actually equal to 2. 2 is natural, 2 is whole, 2 is an integer, 2 is rational. 3i, this is a pure imaginary number. -17 is not natural, it's not whole, because remember, natural and whole numbers don't include negatives. It is an integer, it is a rational. This is a complex number only. Square root of 81, another trick question. Square root of 81 is 9, which is natural, which is whole, which is integer, which is rational. 1/4, the square root of 1/4, this is a tricky question. I'm asking here, what times what is equal to 1/4? Well, to get the numerator, I can do that pretty easily. 1 times 1 is 1, giving us the 1 on the top. On the bottom, 2 times 2 is 4, giving us the 4 on the bottom. So square root of 1/4 is 1/2. It's not natural, it's not whole, but it is a rational number. Okay, let's go through and let's go down here and do some kind of trivia, kind of number trivia. All right, the sum of two integers is always, sometimes, or never an integer. Let's do an example. 3 plus -2. Yeah, it's going to be 1. I can't think of a case where you'd add up two integers and you get a fraction. So I'm going to go with always on this one. Sum of two irrational numbers, sometimes, always, or never, in irrational. So I think in most cases, like pi plus the square root of 2, you've got crazy plus crazy. It's going to be even more crazy. So I was going to say always, but you know what? I thought of one tricky case. Pi and negative pi, these are both irrational, but when I add them, it's 0, which is irrational. So tricky thing here, I'm going to go with sometimes, but really it's almost always. Two crazies are going to be even more crazy. Sum of rational and irrational. So something like 3 plus pi. Well, I've got pi, which is 3.14159, da, da, da. I'm adding 3 to it, so that's going to turn into a 6.1. Yeah, it's going to be a crazy decimal, slightly different crazy decimal, but still crazy. So this will always, oh wait, it's saying rational. This will never be rational. So if you got rational and irrational, crazy plus normal will always be crazy. It'll never be normal again. Difference between two whole numbers. So if I got like 5 minus 2, that's 3, that's a whole number. But if I flip the script, 2 minus 5, negative 3, negatives aren't whole numbers, so this is going to be a sometimes. Difference between two rational numbers. I want you to think about this one. Give it a good guess. And yeah, difference between two rational numbers. So if I do like 3/5 minus 1/8, I don't really want to deal with denominators and stuff, but I know I could, right? I know I could get some kind of common denominator or some kind of thing, and it would be some other fraction, right? So this will always be some other fraction, right? If you get fractions, you add them, subtract them, your answer is always going to be a fraction. It's not going to be a crazy decimal like pi or square root of 2 that goes on forever. Product of two integers, sometimes, always, or never an integer. Think about this one. Okay, 6 times 2 is going to be 12. That works. Negative 6 times 3, negative 18. I'm going to go with always on this one. I can't think of a case where you multiply a couple of integers and you get like a fraction or something. This next one, though, is different. What do you think? Quotient. Quotient means divide. Yeah, if you got something like 6 divided by 2, that's 3. 3 is an integer. But if you got something like 2 divided by 6, that's 1/3, which is not an integer, so we're going with sometimes on that. Product of two rational numbers. Think about this one. You're multiplying fractions. Yeah, we're going to go with always, because if I have like 1/3 times 2/5, it's going to be 2/15. More generally, if I have A over B times C over D, I'm going to have AC over BD, which is a rational, right? It's going to be a fraction. Multiplying fractions, you get fractions. This one I want you to think about. What's your guess? If you multiply a rational and an irrational. So 6 times the square root of 2. You've got normal times crazy. Okay, well, if you guessed always, then you're absolutely right. If you get normal times crazy, you're always going to have a crazy decimal that never repeats. So square root of 2 is like 1.4 something, something, something. If you multiply it by 6, those decimals will still go on forever. This will be crazy. Let us be slightly different crazy decimals. Okay, let me scroll down here. Okay, let's talk about these last couple here. Okay. The product of this one. The product of two irrational numbers. So think about this one. The product of two irrational numbers. So crazy times crazy. Square root of 2 times pi. And that's going to be pretty crazy, right? Square root of 2 never ends, crazy decimal. Pi never ends, crazy decimal. It's still going to be some other crazy decimal. I would normally say always, but there's one tricky case involving square roots that's going to make it a sometimes. Let me give you that example. Square root of 3 times the square root of 3 is the square root of 9, which is 3. So in the case of square roots, sometimes you can get stuff that turns back into normal. So we're going to go with sometimes right there. Product of two real numbers is always, sometimes, or never a real number. Real number is any number you could think of before you had heard about imaginaries. So 6, 10, negative 3/5. If you add or subtract or multiply these, they're always going to be real. Basically, the only thing that's not real is an imaginary. And as long as you're not taking square roots, you're going to be real. So this is always real. Again, the only time you get something that's not real is when you take the square root of some kind of negative number. Okay, the product of two complex numbers, sometimes, always, or never a real number. Let's think about this. Product of two complex numbers. If I have something like 3 plus 6i, and I multiply it by 2 minus 7i, without going and doing all the work, it's going to be, let's see, 3 times 2 is 6, plus a bunch of i's. There's going to be i's in here. So usually, most of the time, when you multiply two complex numbers, you're going to have a complex number, meaning something with an I in it. Okay. Now, when do you get something that might be a real number? Okay, it seems like you should never get something that's a real number, but consider this case right here. What if I had something like 3 plus I, 3 minus I? Let me just put this in a box up here. 3 plus I, 3 minus I. 3 times 3 is 9. I've got 3i, I've got negative 3i, I've got negative I squared. So these ones will cancel. 3i minus 3i cancels, leaving only 9 minus I squared, which is 9 minus negative 1, which is 10. So in this case, a couple of complex numbers multiplied together brings back a very ordinary, very tame, very normal real number 10. So the product of two complex numbers sometimes, rarely, but sometimes will produce a real number. Okay, last little thing, just review difference of squares. X squared minus 9, x minus 3, x plus 3. Same idea here in terms of canceling out. This is going to be negative 3x. This is going to be positive 3x, leaving behind only x times x, x squared, and 3 times 3, 9 right there. All right, so follow the same pattern here. X squared minus 16, x minus, you guessed it, 4, x plus 4. This next one, do this in your head before I continue. You got it, x minus 10, x plus 10. So just want to refresh that pattern, difference of squares. Okay, so homework for today, guys, is this. Maybe this is being slow. Okay, right here. So homework for tonight is this thing right here, assignment 4.1, types of numbers. And you're going to go down here, and there's only 3 questions. It's pretty easy. So you're going to take this one, 2/3. Is 2/3 real, rational, integer, whole number, irrational? And yeah, so go ahead and work through those. There's only 3 questions. For number 2, you can kind of think of the different circles, right? Every real number is a rational. Let me just give a little refresher on this one. Okay, every real number is a rational number. Let's just draw those circles again. You've got your natural numbers, you've got your whole numbers, you've got your integers, you've got your rational, and then you've got your reals. Okay, and then over here you have your irrational numbers. Okay, so every real number is a rational number. Every real number is a rational number. And that's not going to be true. The opposite is true. Every rational number is inside the belly of this big circle of real numbers, but the converse isn't true. So that's not true. Every rational number is an integer. Let's check that out. Every rational number is an integer. That's not true either, because 2/5 is a rational number, but it's not an integer. Integers are things like -3, 7, -11. All right, so the first 2 we've struck out. Third one, every natural number is a real number. And that's definitely true, because natural numbers are in the very heart of real numbers. So these are the realist, naturalist of numbers. So we're going to check that box. Anyways, I don't want to give you all these, but you get the idea. Use these different circles in your notes to kind of answer that question. Okay, guys, that's it for today. Hope you have a terrific snow day, and I will see you later.